that engineers have designed with great care to make sure of economical results. But the principle is still the same. The carburetor has but one purpose, and that is to mix a little drop of gasoline with a great big bubble of free air. In a one-cylinder engine made for laboratory experiments, parts and many types of moving surfaces in the automobile engine. Consequently, the engines in our cars today use all three methods of lubrication.
A slug is placed in the cup-shaped die of a power press. Then a mechanically operated punch strikes the slug a single downward blow with tremendous force, causing the metal in the slug to squirt up around the punch. When the punch is withdrawn, the aluminum tube remains in the die and is knocked out. Since the punch is a little smaller than the die, the space between the two determines the thickness of the side walls of the tube. And likewise, the base of the plunger and floor of the die determine the contour of the end of the tube. Another type of extrusion, impact extrusion, starts with the blanking of circular slugs from sheet or plate. In our refrigerator, we could use one of several different types of pumps or compressors. For example,
bath of oil so that moving parts can splash into it for lubrication. We can provide a supply of oil on a higher level so that it will trickle down through a system of tubing onto the moving parts. The force of gravity furnishes the power to carry a steady flow of lubricant where it is needed. If we want an extra amount of lubrication, we can force a stream under pressure directly onto the sliding surfaces. By controlling the pressure, we can control the lubrication for different speeds. There are many. Here, instead of a generator, we have a water pump. These glass pipes take the place of wires connected to a water wheel motor. When we spin the pump around, we set up a movement in the water which represents the flow of current in the generator. The current flows from the generating pump to the motor and back again. And the more water we pump, the faster the water wheel motor will spin. Let's add a glass tank to see how a storage battery works. Now we can store up power and use it to run the water wheel even when the pump is stopped. Of course, in the automobile, it isn't quite as easy as all that. But this simplified system shows how the battery stores the electrical current and releases it as it is needed. It has to supply power for the self-starter and furnish a hot spark for the spark plugs. Electric lights add to the load, and in order to supply the changing needs, the generator must be carefully controlled. We don't want to put too much energy into the battery, overcharge it. And we don't want to put too little energy in, or we won't have enough to run extra equipment.
Buying raw materials, making more widgets, a number one widgets that any customer would be glad to have. And while widgets are being bought and sold at one end of the factory, raw materials are being sold and bought at the other end. So, with everything humming along smoothly and everyone working for somebody else, money seems to travel round and round in this widget business.
push in the opposite direction by simply moving the valve to apply the vacuum to the other side of the chamber. Notice how the smoke shows the air moving in and out as the vacuum changes sides. And notice that almost no effort at all is required to move the valve. The air does all the pushing. The plunger follows the slightest movement of the valve.
Two wheels are mounted on separate axles and supported by a frame so that they can revolve freely at different speeds. Let's fasten a spoke on the inner end of each axle so that by turning the spokes we can turn each wheel separately. With a bar or crosspiece, we can turn both wheels in the same direction at the same rate of speed. Let's get something to hold this bar in place so that it will press against the spokes. Notice that this support is not locked to the axle. It turns freely. Now we can spin the wheels by rotating the support. This is fine as long as both wheels are able to turn at the same speed. But let's see what happens when we go around the corner. With this arrangement, we cannot drive one wheel faster than the other. And if we stop one wheel, the other wheel won't budge. Let's put this bar on a pivot so that it can swing in either direction. Now, the bar can still turn both wheels at the same speed. And because it pivots, it lets one wheel turn even when the other is stopped. But if turned too far, the bar will swing around until it won't drive the spokes that turn either wheel. We need another crossbar and more spokes to carry on the job. When we stop one wheel, the crossbars will continue to push the spokes of the free wheel around. As long as both wheels are free to turn, the bars do not swing on their pivot and the wheels move at the same speed. Now we have the working principles of a differential. To adapt the model for use in an automobile, we will have to make a few changes. In order to reduce the jerky action caused by wide spaces between the spokes, we will put in more spokes. Further filling in the spaces between the spokes gives steadier, more continuous action, and changing the shape gives firm, constant contact. Now we can make the gears thicker and stronger, and we have differential gears. The edges are cut so that they will fit together more smoothly and silently, and another gear is added to share the work of driving the axles. The principle is the same. In order to turn the support and drive the wheels, we can fasten a large gear here, connected by a smaller gear to a source of power.